Okay, so I tested my microphone, so the audio should be working. If you have not completed the notes from the PDF version and you have not done the Desmos, do the Desmos first. Figure out this setup here with the book. Okay, here we go. So I'm going to put that here. Do Desmos first. If you have not gone through the Desmos pages, you need to do that first. It's in the agenda. So make sure you do that. So you saw on a graph what it looks like for function operations. We're going to look at algebraically. So you can see I've written down that box that we talked about in the notes. So if you haven't written that down, go ahead and write that down now. Off my camera there. And then we're going to talk about the algebraic method of function operation. So the first one they gave us was this f of x equals 4x minus 3. And they also gave us g of x equals 2x squared plus x. So notice these are both functions, right? This is a function of x. This is a function of x as well. These are just the names of the function, f of x and g of x. Those are just the names, okay? It's telling us that it's a function. Now, our first operation in Desmos was this f plus g of x. So in order to do that, what I'm looking at is a sum, right? Up here, we're finding the sum of the functions. So I know that I can add my functions together. So that looks like this. If it's f of x plus g of x, I know that I can add them together. So I'm going to say if the function of x is 4x minus 3, and the function of g of x is 2x squared plus x, 2x squared plus x, I know I can add those together, okay? So it just becomes simply combining your like terms, right? 4x and x. So I have a 2x squared and then writing it as in descending exponential order. So 2x squared plus 5x minus 3 is my new function. So we're going to call this f plus g of x equals 2x squared plus 5x minus 3. So that's your algebraic method or model. What we saw on Desmos is that it was a parabola. So we know this follows our quadratic function, right, in the way that it would look. So we know that we are correct. Okay, so let's look at that next model. I think we were subtracting, right? F minus g of x. So we're going to do the same thing. This is the same as f of x minus g of x. So we'll take our functions f of x and g of x and subtract them, 4x minus 3, and we have 2x squared plus x. Now remember, when we subtract, we're subtracting the whole function here, right? So when we do that, we have to distribute that negative, the additive inverse. So we're distributing that negative 1 over. So we have 4x minus 3 minus 2x squared minus x. Now we go ahead and combine like terms like we did when we added them together. So we have a 4x and a negative x. We're going to write it in descending exponential order. So we have negative 2x squared plus 3x minus 3. So this is f minus g of x. So you can see the difference in when we add and subtract. Just like order, combining like terms, that's it, right? We're adding and subtracting polynomials. Let's move on to another example. And we're gonna do, let's do product. So we have f of x equals x squared and g of x equals x minus 3. So when we are multiplying when it's f times g of x, then we can do this, f of x times g of x. These are just additional steps here. You don't have to write those steps down when you're actually working on them. If you know you're multiplying, you can go straight into multiplication. So I have x squared times x minus 3. So I have a monomial out here. I have a binomial. I'm going to distribute that x squared over. So we have x cubed minus 3x squared. Give myself a little bit of room to write my exponents. I don't have any like terms to combine, so this is going to be my answer. Notice that when we multiplied our functions, that it increased our power here. It increased. So this is f times g of x. Okay, let's try one more. We're going to find the quotient of these. Quotient. So we have same thing, right? F of x equals x squared and g of x equals x minus 3. So if I want to find f divided by g of x, then that's the same thing as me saying f of x divided by g of x, right? So my function would be x squared divided by x minus 3. Now notice in our quotient, when we find the quotient of, this is f divided by g of x. When we find the quotient of two functions, we have to be mindful of the denominator. So just keep in mind that your denominator cannot be 0, right? Or then it would become an undefined function, right? So I want to find out, so it cannot be 0, right? Our denominator cannot be 0. So I'm going to solve for this to figure out what the restrictions on my domain is. X cannot be 3. So this is your answer, except I want to put a little note about my domain. X cannot be 3. And I simply do that by setting that not equal to 0 and then solving. Okay. So that's your answer for your quotient. All right, so here's some try it. Let's try some of these. I'm going to give you a couple of examples and you try these on your own and we're going to go over them in class together. So let's see. So if f of x equals 2x and g of x equals x squared, you're going to find f plus g of x, okay? So there's your first try it. There's your second, right? If f of x equals 4x minus 3, then g of x equals x squared minus 9, find f minus g of x. Okay, so give you a couple of spaces to work that out. If you want to pause it and look over those, you can. Here's your next one, f of x equals 1 divided by x, and g of x equals 5x. Find f times g of x, okay? And then your fourth one here, your last try it. Let's do this one. If f of x equals x cubed, then g of x equals x squared plus 1, find f divided by g of x. Don't forget on number 4 to find the restrictions on your domain. When I post these notes in PDF, I'll post the answers as well, so you can check your answers as you go. All right. make sure that you come back to class with these notes already taken. That way we can move on to some fun activities. See you soon.